Starting with number 2. First question I have, is this a law of sines or law of cosines problem? Law of sines. And you can tell it's law of sines because it's not side angle side. The angle you have is across from the two sides. And it's not side, side, side. You can also tell because they're proportional. So 50 goes with the 31. And B goes with the 7. Skinny triangle, hard to draw the arrows though. Okay, so I have sine 50 over 31 equals sine B over 7. Let's multiply. Divide both sides by 31. Okay, now you have not B, but sine B. Do you remember? Inverse, right? Any questions about number 2? Okay, quick survey. Who feels better than they did yesterday at this time? Who feels worse than they did yesterday at this time? None of you are going to answer my super exciting survey? Or are you just still trying to decide? I didn't sleep again. I don't know what my problem is. Okay, number 4. What's this one? Stare at the middle table next to you. Side, side, side. Thank you, dear. Side, side, side is law of cosines. Okay, now it says it wants measure of angle C. So I'm going to mark that and make my arrow across. So that helps me remember to start with the 17. 17 squared is 18 squared plus 30 squared minus 2 times 18 times 30 cosine of C. Okay. 17 squared, 349, 289. Okay, then you combine those two, 18 squared plus 30 squared. Combine those three. Okay, rescue out the 1224 before we do something silly. Don't forget to invert. Okay, now can you guys find the resource page from yesterday, please, with number 2 and all of your graphs from Desmos? Okay, I just want to check them quickly, and please ask questions if you need to. These are really important that we make sure we have these correct. Here's number 2. Please check your number 2. Here's number 4. Please check your number 4. Flip when you're ready. Number 6. Now this part right here, the factored form, is optional. You do not have to find that. I used Desmos to cheat to find that. Before the end of the chapter, you'll know how to do that properly. If anybody wants me to explain how I got that, I can. Yes, honey. The infinities? No, it just as long as they're over here. Okay, here's number 7. The last one, here's number 8. If you guys have any questions about any of these, it's super, super important. Of course. Anybody need anything? Okay, so we're not going to write on this today, but we're going to use it just to look at in a little bit. So don't like put it away, just set it off to the side. Um, this you're not doing this, don't worry. Okay. Hmm. 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 Huh. Hmm. Seems like an awful long time for loading of that. Still doing it? Mm, hmm, hmm. Okay. Today we're going to write down what we learned yesterday with the double root, triple root business. And then a couple of people, I was really impressed. Yesterday, some people came over and asked me, how do you know if you start at the top or if you start at the bottom when you're drawing the curve, if you don't have Desmos or your graphing calculator? And I was really impressed with that conversation so early. And so that's what we're going to talk about today is like, where do you start up or do you start down? Do you end up or do you end down? And the whole thing has to do with the A value. Um, so that's what we're doing today. And then homework is 32, 33, 34, and 36. And here's my joke. It says hierarchy in the junk drawer, and the scissors say, and this is our great ruler. Do you like this one better than yesterday? Do you get it? Because it's a ruler. How is that math related? I don't. What did I even Google to find that joke? That's the question. Because I was clearly trying to find polynomial jokes, and that's, I don't know. Okay, so we're basically going to review what we did yesterday and then add the part about would you start up or down. Okay, notes, graphing polynomials. The first thing we learned was some vocab. So I'm going to start with an example. X minus 2 in parentheses, we call this a factor. It's a factor when it's in the parentheses. When we take it out of the parentheses, which I meant to do there, we put x equals, and then we switch the sign. So x minus 2 becomes x equals positive 2, and we call that a root or a 0 or a solution. All three of those words mean the same thing. And if we take that root 0 or solution and put it into a coordinate point, that is called an x-intercept. That was the first thing we learned yesterday. Or review. Okay, then we learned about some new cool stuff, double and triple roots. Okay. Next, we learned what a double root was. I'm going to use an example again, because I just feel like that helps the most. And a double root has a squared on it. So this is a single root. This is a double root with a squared on it. And that is the factor. X equals 2 double is the root. And 2, 0 is the x-intercept, and it does a bounce off of the x-axis. Draw a little baby graph over here. Put that point at 2, 0, and then show the bounce. So it comes to the x-axis, hits it, and then bounces off, and that's what a double root does. Also could be coming from the bottom. It doesn't matter if it comes from the top or the bottom. What matters is that it hits the x-axis and bounces off like a ball. Okay, then we learned about the triple root. Triple root has a cubed. So single, double, triple. This is its factor. You say x equals 2 triple. Your x-intercept is still 2, 0, but this makes an inflection point. So you put your dot at 2, 0. You can come up from the bottom or down from the top. It doesn't matter. But what matters is that you flatten out at that point and then continue on. Okay, so if you were absent yesterday, you're pretty much caught up now. That's what we did yesterday. Do you guys have any questions about any of this stuff before I move on to the which way the arrows go thing? Okay. So now we're moving on to the new stuff. Let me move that over. Okay, we're gonna draw four little pictures here. Two for even degree, two for odd degree. If you have a positive a value, you guys all know parabolas open up when you have a positive a value. Same thing for polynomials, they open up. So both arms up if you have a positive a. Okay, what do you think about a negative a then? Yep. Hmm. Apparently I don't know how to spell the word arrows. Okay, so at this moment, I want you guys to go find your graphs from yesterday, the ones we were just looking at from number 2. Okay, take a look at graph 3. Graph 3 has an even number degree, so 4 is an even number. What's the a value for this graph? What is it if nothing is there? I heard it. 1, right. So if there's nothing here, there's a 1 right there that we didn't write. So a is 1, and it's positive 1, which means both arrows are going up. Does that make sense? Okay, now find me graph number 5. Even degree, negative a value in the front, and now it's flipped and both arrows are going down. Did anybody pick up on this yesterday? Yes, me. Oh, hold on. That's the next thing I was going to say. Okay, now odd degree ones. So here's my question. On the stuff we did yesterday, are there any odd degree ones with a negative a value? Oh, yep. Look at number 4. Okay, so let's just look at graph 2 and graph 4 real quick. Graph 2, has a positive A value. A is 2, and it starts low and ends high. So it's increasing as it goes. Contrast that here. Negative A value started high, ended low. Does that make sense? Got it? Okay. Well, all right. Set this up. Okay, so what I want you to do is I want you to set this up, and then I want you to get your graphing calculator and graph both of those on the same screen. You don't have to all do it, just have at least one person in your group do it so you can pass it around. Really quick question, on your graphing calculator, is the first one blue and the second one red? Satisfying. If one person could get it at the group and then pass around the calculator, that would be great. So everyone can see. So is this surprising to you at all? Like the outcome here? So this is the picture. If you just had this picture, could you tell them apart? Okay, so this is the reason that we're not doing anything other than double and triple roots in math 3. Because a fourth, I don't even know, quadruple root, it's still a bounce off the x-axis. And a fifth root is still a wonky inflection point. So you can't tell. Okay, so all we're going to do on this problem is we're just going to sketch these. So just go to 1, sketch the blue one like a parabola, and then however you want to, if you don't have red on you. Sketch the other one like more like a U shape. So in this class, we can only tell the minimum degree with just the graph. Means we see a bounce. It could be any even exponent. It could be 2, 4, 6, 8. We're just going to go with 2 in this class. We're going to go with the minimum. Keeping it simple. So if you're wondering why I stopped with the triple root, didn't keep going with quadruple and whatever, that's why, because they do the same thing. Okay, are you ready for AP art class now? Do you feel like you've kind of been in AP art class yesterday and today with these yesterday during my fifth period, some people's graphs were so bad that they got the giggles really, really hard and then couldn't concentrate because their graphs were so terrible. Mrs. Abbott, why did you do number 25 and then number 24? Because it's taught better that way. Okay, so our goal here while you're writing is to determine whether or not these graphs have what degree they are. We can't tell exactly, we're just gonna go with the minimum because we're in math three. And if they have a positive or negative A value. Okay, so sketch it, then take a look back at your previous page. Okay, so this first one. First question I have for you is, does this have an even or odd degree? Odd, right, because it's got one arm up and one arm down. Okay, what is the minimum degree of it? Well, you can tell by the changes of direction. So this is 1, 2, 3. So this is a minimum degree 3. Okay, now for the end behavior, I'm going to do two things. I'm going to label my picture, and I'm going to say if this one has a positive A value or a negative A value. So left side is low, right side is high. Does this have a positive A value or a negative A value? Positive, right. Okay, you guys try B on your own. What's the minimum degree? What are the arrows doing? Does it have a positive or negative A value? Perfect. So changes of direction, 1, 2, minimum degree 2, negative A. Okay, we have one more of these. It's a challenge one. I want to see if you guys can do it. Okay, let's check your work. 1, 2, 3, 4, 5. Minimum degree 5. It starts high, ends low. So that means it's a negative A value. How'd we do? Okay, we have one more question. It has an A and a B, and this is basically what a quiz question would be. So combining what we learned the last 2 days into a quiz question. So to pretend now for this one that you walked in and you're going to take the quiz on whatever that day is, which is not for a while. By the way, do you guys know that the block days next week are Tuesday and Wednesday? Just mentally preparing you for that. And then the week after that, we have no block days. I know, all regular days, but you guys only have, you have a 4-day weekend. Yeah, exactly. That's why you have to choose your classes and whatnot. What? They wanted to do the elective fair on Thursday because it's like open house also, but they wanted you to be able to go to every class that day. They didn't want that to be a block day. Correct. Because it's a 4-day week, so there's only 3 days that week. So they just did 3 regular days. I got nothing. I just work here. I show up when they tell me to come. Yes, Preston? Uh, that's my favorite question. It's the second week in February. It starts like the 7th, the 8th actually, I think is the Friday. Or the 7th is the Friday. The 7th is the Friday. And then it goes 8 and then all the whole next week. And I'm going to Disneyland. My favorite. Okay. All right. So I'm Mrs. Talbot, the student. I guess I wouldn't be Mrs. Talbot. I would be Leanne, the student. And I came in, okay, and I sit down and they're taking this quiz. Okay, so this would be my approach to taking this quiz. Remembering I have no graphing calculator. So I have to figure out how to graph this with no graphing calculator, just learning the stuff that we learned today. Okay, first, I would say to myself, okay, student, first thing I notice is that this is in factored form and there are 3 x's, which makes this degree 3. Degree 3 is an odd degree, and I have a negative A. So that means that my graph is going to start up high and end low. Okay, then I would say, okay, I can graph all 3 of these dots. This one is 0. This one is -1. This one is 3. 0, -1, 3. They're all single roots. There's no exponents on any of these, so I'm just going to go straight through the x-axis. And so it's telling me to start high. So start high, single root goes through, single root goes through, single root goes through, done. Do I care about the height of the bumps? No, I don't have a graphing calculator, so I'm just sketching it. Yes, honey.
Can you do it with not a value? Is that just positive?
It's just one, yeah. So A is one if there's, and it's positive one. Okay, so excellent question. So degree 1, 2, 3, 4. And this one has a 1 in the front that we don't write, so that's a positive A. Even degree, positive A, it's going to have both arms up. So it's going to look something like that. I have x equals 1 is a double. X equals -2. X equals 4. So 1, -2, 4. To keep in mind, this is my double. So this says start up high. This is a single, so it passes through. Double is the bounce. Single passes through.